Hello, let's start with chapter 3 that is on cloud computing. We know that cloud computing is a technology that allows individuals and businesses to access and manage computing resources over the internet. And when we say these resources are basically the servers, storage, databases, networking, software, analytics, all provided on demand by cloud service provider. See, we all are using cloud computing. We all are using Gmail. Where is our email stored? It is stored on the Google Cloud. Similarly, our contacts, our photographs, our location data, they are all stored on the Google Cloud. So we all are using cloud computing for storing our data. We can also use cloud computing for accessing some software, databases, servers, right? For example, you must have used the software Canva. So where is that software? Did you download it in your PC? No, you are using it as an online software. So it's a software that runs over the cloud. You are accessing its functionality using the internet. Then cloud computing is a model for delivering computing services over the internet, allowing individuals and business to use software and hardware that are managed by third parties at remote locations. Now that the services are available, who is managing them? We are not managing. We are just using those services. They are managed by the third party, the cloud service providers, right? It's just like you buy a house and you are maintaining it. You are using that house and you are maintaining it. But if you take a rented house, you are just using that house. The landlord or the landlady is maintaining it. So if there's any problem, you go to the landlord and it's his or her job to get it repaired and to get it maintained. Same is the case with cloud computing. So it offers faster innovation, flexible resources, economies of scale. Major companies like Google, Microsoft, AWS today provide cloud services. We are using it for storage, backup, and recovery of data, delivery of software on demand. So we are saying on demand because you use it when you want to use it, right? You have not purchased any software. You are paying for only what you have used. That's it. Development of new applications and services, streaming videos and audios, how this can be done, we will see. So advantage of cloud computing includes flexibility. Why flexibility? Because organization can easily adjust their computing resources. For example, see, if there's a marriage in your family, you need 10 chairs, but you have only 4 chairs in house. So what you can do is take 6 chairs on rent. If you need it for 1 day, you pay rent for 1 day. If you need it for 10 days, you pay the rent for 10 days. So it is flexible. You are paying only for the computing services or the resources you are using it. Scalability means you can anytime increase or decrease your demand. You increase more, you get more, you pay more. And when you don't have a demand, you take less and you pay less. Then cost savings, because instead of investing companies resources or capital in buying those resources, you are just using it as per your usage demand. Then it also helps you to collaborate and access data from any location with an internet connection. Some challenges of cloud computing include data security. Of course, when you are putting your data on some other server, on a third party server, so maybe if it's Google, but there is always a threat to data security. Vendor lock-in, because it is difficult of migrating data and applications between cloud providers. You already know, um, if you go even in real world, if you have to change switch your rented house, it is not that easy. There is some overhead. Same is the case with cloud computing. Then reliable internet connectivity is must to use the cloud services. So we basically have three types of clouds: public cloud, private cloud, and hybrid cloud. As the name suggests, public cloud means it is, see, you have public transport, private transport, and hybrid transport. In public transport, you're using bus, metro. So it is cost effective, scalable, maintenance free, accessible, and but you have to, but there are security concerns, right? Same is the case with a public cloud. There are compliance issues, performance variability. Sometimes we have good service sometimes we don't have. Private cloud may you have your own car, by your own vehicle you are going, so the security is enhanced, it's customizable, better performance and easier compliance because you are only handling it. But it has a higher cost maintenance, you have to maintain it, manage the resources, scalability challenges because today you have you have resources to fulfill 100 demands, but if the demand is increasing, then you either have to invest, then I mean then there are scalable issues, and in case you have 100 resources but you need only 80, so you wasted the money for rest of those 20. So that was the disadvantage of private cloud. In hybrid cloud, it's hybrid means a mix of two technologies, so it's a mix of private and public. So hybrid may we have flexibility, cost efficient, scalable, and enhanced disaster recovery, but the drawback is complex management. If you take the real world example, your hybrid cloud can be, you can take it as a Ola Uber cab. So it is private also, it has the features of private as well as of public. So if you're going by cab, you are spending more than your private vehicle, but less than your private vehicle, but more than your public bus or metro, right? So data security challenges is there because it's a mix. You public cloud is involved here. Then integration issues, potentially increased cost. Now, based upon why you are using clouds for cloud systems, network systems, storage systems, database, software applications, you can categorize them into different groups. For example, we have SaaS, PaaS, and IaaS. So IaaS means infrastructure as a service. When you are using the cloud services for server, storage, networking components, you are using basically IaaS. When you're using the cloud services for platform operating system or so we are using it as platform as a service. With platform you can connect with the word operating system. So when you are developing an application, you need to test on different operating systems. So instead of investing money to buy different operating systems, you can take those operating systems through cloud. Since software as a service, when you have software as a service, you can um, you know take software, use software from the cloud. For example, as I gave you Canva, then even for example, you need the Turnitin software, so it's over the cloud. You want to use it for 1 month, use it. If you want to use it for 3 months, you want to use it for one, so you just pay and then you use it as per your demand. So that is software as a service. If you see this table, there is there are examples and there are key features. For example, IES में key features are it's scalable, but it talks only about computing resources, scalable and reliable storage. Network, it uses VPN, virtual private networks, load balancers, and users manage the operating system, applications, and runtime environment. Then platform as a service, when you have you can manage applications without the complexity of building and maintaining the underlying infrastructure. Companies like Google, Microsoft provide these services. And development tools here is integrated development IDEs, version control, collaboration tools are all provided as PaaS. Then all middleware software, database software, application hosting software are provided through platform as a service. For example, if you have a website, you have to host it. You can use cloud services. You want a database to store the record of your clients or customers, you can use again as a PaaS. Then software as a service, when the software is delivered as used via the web browser without needing to manage the underlying you don't have to manage, you just are using it. So you have full functional control software applications that are accessible online. And service provide, it is the job of the service provider to handle software updates, security, infrastructure. You don't have to worry about anything. Now, if you see this diagram, what it shows here is infrastructure as a service. It provides virtualization, storage, servers, and network. But when you talk about platform as a service, it apart from virtualization, storage, servers, and networks, it also provides support for middleware and guest operating system. If you say software as a service, it provides access to all these uh, services provided by IaaS and PaaS. So here's a comparison between IaaS, PaaS, and SaaS. PaaS provides a virtual center for information storage and platform creation, app development, application development, and PaaS offers virtual platforms and tools for creating, testing, and deploying applications. And SaaS delivers web-based software and applications for business tasks. IaaS access to resources such as virtual machines and virtual storage. PaaS provides runtime environments and deployment tools. So here it is providing virtual storage, virtual machines, and here PaaS is providing runtime environment and deployment tools, whereas SAS provides ready-to-use software applications. Primary users of IaaS is network architects and IT infrastructure managers. So all infrastructure managers only. But if you are a software research engineer, then you are using SAS, right? For developers, if you are only working as a software developer, then you would be using PS most of the times. Then scope of the service provides infrastructure only, provides infrastructure plus platform, and provides infrastructure, platform as well as software. Now, apart from IaaS, PaaS, and SaaS, we can also have network as services as a cloud. For example, you pay only for the network that you are using. Desktop as a service, your desktop environment can be taken again from the cloud as a cloud service. Then storage as a service, may you are using the storage infrastructure, and database as a service, we're using just the database without the need for installing and managing it. Then you can also use data as a service. For example, if you need some audio, text, images, video data for analysis, data is never free. I mean, there is only limited data that is freely available over the internet for analysis. But if you want, you can even take it as a service. You can pay for what data you are using. Then security as a service, you just need here security components, no other components, and identity as a service where third party providers provide authentication infrastructure, for example, access control, username, password, login information, whatever is there to prove your identity authentication. के लिए, all those services are provided as identity as a service. Then there are important terms like virtualization and containerization, and we need to understand the difference between the two. Virtualization and containerization are both technologies designed to optimize risk. The first and primary concern is resource utilization and improve scalability in computing environments, but they operate in how they operate is different, but the goal is the same. What is the goal? To optimize resource utilization and improve scalability. Now, virtualization of allows multiple for example, see if you are a software developer and you need to test your application or to build your application on Windows as well as Unix, Ubuntu, Linux. You're building it for four operating system, for example, right? So one option is you should buy all the four operating system. The other is to on this see on your PC you can have only one operating system. So you can create virtual machines. You can use virtualization to create different versions of hardware platforms, operating systems, storage devices, and network resources. You can partition your computer resources into different partitions. And on each partition, you can use a different operating system. So that is called virtualization. Virtualization means that there is only one resource set of resources, but you can partition it internally to give a flavor as if they are on different machines. So that is why it is called virtual machine. This process of partitions physical resources such as CPU, memory, and storage into multiple virtual machines, each operating system as if it were on independent physical machine. Right? For example, in the same house, um, if two families are living, so the two families live in separate rooms, and it is for them like they are living in a separate house, even though they are under the same living in the same address, right? For example, in your house we have different floors, and in on each floor there's a different family. So they are so the same plot has been virtually divided as if they are in independent houses, right? So you can take that example to understand. Now, what are hypervisors? So, which virtualization use hypervisors or virtual machine monitors? So, नाम से ही पता, from the name you can detect. Monitors, virtual machine monitors. They what their purpose is to manage. Now we have virtual machines, so we need a monitor to monitor them. So that is the job of hypervisors. Right, then virtual machines, each virtual machine runs its own operating system and applications. If it functions as an independent physical machine with it having its own CPU, memory storage, and network interfaces. Now, what are the advantages and disadvantages? So, virtual machines provide isolation where they are fully isolated from one another, which means issues in one virtual machine do not affect others. Resource utilization. Virtualization allows better utilization of physical hardware by running multiple virtual machines, and flexibility. Virtual machines can be easily created, modified, and managed, which improves scalability and resource allocation. The disadvantage being each virtual machine requires its own operating system, which leads to significant resources overhead. See, if you have different operating system on the same computer, so there will be some overhead involved. If you are giving the same house, you're renting it to four different people, so there the overhead will be, of course, more. Right, in performance, VMs can experience higher latency, lower and slower performance due to additional layer of abstraction provided by hypervisor. So now that in virtual machines, of course, if you compare it with a single machine running only one operating system and a machine running four operating system, of course, this performance would be slow and there will be higher latency, higher delays. Containerization is a lightweight form of virtualization. It encapsulates applications and their dependencies into isolated units. We'll see the diagram to visualize. Unlike traditional VMs, containers share the same operating system. So this is the main difference. Containers share the same operating system kernel but operate in separate user spaces. We can see here the host operating system is the same and we have different applications put in an individual box. So this is called containerization. So each application is in a separate container. So advantages and disadvantages. Efficiency. Containers are lightweight and use fewer resources as compared to VMs because they share the same OS. Now, containers can run consistently across different environments, making them ideal for deployment, testing, and production overflows. And the speed is also high because there is minimal overhead, which enhances deployment speed and scalability. But the disadvantage is isolation. Containers are offer process level isolation but are not isolated as VMs. VMs mean it is truly isolated, but here only process level they are isolated, which can be a concern for security because operating system is the same, right? Then while containerization simplifies many aspects of deployment, managing a large number of containers requires again another overhead. So to see the comparison between the two technologies, let us see. Each VM has its own OS and is fully isolated, but containers share the OS and are isolated and but are isolated from each other. VM requires more full hardware resources. Containers are lightweight and share less resources comparatively. Higher overhead in case of VM and lower overhead in containerization. VMs are therefore less portable and containers are highly portable. VMs are slower due to OS boost process, but containerization is faster. Then you can see its ecosystem is more mature in case of VM and it is just evolving in case of containerization. Use cases. VMs are ideal for running diverse operating systems, but containerization is best for microservices. Now, the last topic in this chapter is cloud security, which is a specialized area of cybersecurity focused on protecting cloud computing environments, applications, and data. It involves safeguarding your digital assets, data, and because data breaches and cyber threats are very common these days, so we need technologies and protocols to secure our data. When we talk about cloud security, we often talk about data privacy. And there are regulatory compliance which the organization should follow to maintain privacy, be data sovereignty, data remnants, how you are going to take the backup, internal threats. Internal threats means threats from the employees, internal employees of the organization. External threat like malware, attacks, phishing frauds, then data loss. All the when we talk about cloud security, we consider all these issues. Now, just let's have a comparison between public, private, and hybrid cloud in a detailed way, because then we can better talk about security. Public cloud, we know that the security is least in case of public cloud. Public cloud is less expensive as compared to other two variants, accessible to public over internet, but private cloud is accessible only to restricted people. And when we talk about hybrid cloud, it offers a combination of public and private access. Public cloud is more scalable as compared to private and hybrid cloud. Public cloud is operated by third party service, private cloud specifically by the specific organization, but a hybrid cloud can be operated by a combination of third party as well as the organization. The pay model is public cloud is pay as you go. Private cloud offers various private pricing models based upon your usage, and hybrid cloud is a mix. You can choose. Then stores data at multiple organizations. Public cloud it is shared by multiple organizations, but in a private cloud it stores data only of single organization. A hybrid cloud stores data in both public and private clouds, providing enhanced security in public cloud. So you can tell the confidentiality or the importance of data, and likewise you can store it either in the public or the private cloud. Now, when we talk about data security in terms of these public, private, and hybrid cloud, we say that protect data. The data can be protected through encryption techniques and secure storage practices. Then managers use authentication and access control methods to protect data from malicious use. Then governance, we involve enforcing there should be security policies, threat detection, and incident response planning, uh, activities that should be performed. Then data retention and business continuity. So even if there's a data breach, or the data backup and disaster recovery strategies should be deployed. Then legal compliance, which ensures adherence to the regulations related to data privacy and protection. Data storage, why sets what sets cloud security apart? Because data storage, traditional IT models often relied on on-site data storage, providing organization with full control over the IT. But here the data is not stored by the organization, it is stored by the cloud service provider. So it is different from traditional models. Cloud environments offer rapid scalability and modular infrastructure, allowing organizations to quickly adapt to changing needs. Cloud some see in if you in traditional models, it takes time to adopt a new technology and a new way of securing data, but with cloud it's the responsibility of cloud service provider, so that changes can be adapted quickly by the business, which is indeed an advantage. Then cloud system interact with a variety of other system and services, and cloud systems involve continuous connection between providers and users. Therefore, there are network connectivity risks. Then there are different companies, as we said, that provides cloud services over the internet. Major of these are Microsoft, Google, and AWS. And through their platforms, they provide services for server, database, storage, analytics, networking, software, and intelligence.